This is now our last example in finding the Laplace transform using the second shift theorem. When you check at this example here, it is both a combination of first shift theorem and the second shift theorem all combined together. And by the first shift theorem, we know that the Laplace transform of exponential positive or negative a t of our function f of t is equals to, we first get the Laplace transform of our function f of t, and then to the term of s we come and do our shifting, which is going to be a positive or a negative. This is the first shift formula. And the second shift formula, we understand that it is the Laplace transform of t to the power of n. Our function f of t is equals to, we come and get power of n all over dn. We come and multiply by the Laplace transform of our function f of x. These two, we are going to use them concurrently. So we are going to start with the Laplace transform of, because in the first shift theorem, we must first get the Laplace transform of our function f of t. And by the Laplace transform of our function f of t is equals to the Laplace transform of cos 5t is equals to s all over s squared we add to 25, which is equals to a squared. From this point now, we can come and get the first shift method because of our exponential here. And by this first shift method, we are going to have exponential 3t is going to be equals to cos 5t is going to be equals to, we are going to use our formula whereby we understand that cos 5t is equals to s all over s. But to the term of s, we do our shifting here. Our function f, but to the term of s, we do our shifting. To mean that here we are going to have a negative of 3. A negative of 3. Everything will be squared here. We come and add to 25. This is what we refer to as the shifting. Let us come into our first shift theorem formula. When we are having a positive here, after carrying out the Laplace transform of our function f of t to the term of s, when we are having a positive here we are going to have a negative, and when we are having a negative here we are going to have a positive. When we come here, we are having a positive of 3t. We must have a negative after doing our shifting. And by this is what we refer to as the first shift theorem. After finding the Laplace transform of our function here using the first shift theorem is when now we get to our second shift theorem, because it is our term of t. And now we are going to have the Laplace transform of t exponential 3t cos 5t is going to be equals to, here now we are going to take this term as our u, and whatever we are having on the denominator, we are going to have it as our v. To mean that now here we are going to have the Laplace transform of s, we subtract from 3 all over. We can open our bracket here, and by opening this bracket, we are going to have s squared. We subtract from s we multiply by 3, we multiply by 2, we are going to have 6s. We come and take negative 3 squared, we are going to add to 9. We add to 25. These two, when we add them together, we are going to have 34. So this is now the simplified form of our function here. Let us now use the second shift theorem. And in the second shift theorem, we understand that it is the Laplace transform of t exponential 3t cos 5t, which is going to be equals to n raised to a power of 1 d power 1 all over, because here we are having t has got a power of 1 all over ds to a power of 1. We come and now insert, this is now our function f of s. We come and now insert our function f of s, which is going to be s we subtract from 3 all over s squared. We subtract from 6s, we add to 34. Let us now use let us now use the quotient rule in finding the differential of our function here. We understand that our u is equals to s we subtract from 3. du with respect to ds is equals to 1, because when we differentiate this function here, we are going to have 1. Our our v is equals to s squared. We subtract from 6s, we add to 34. Our dv with respect to ds is equals to 2s. We differentiate our function here. We subtract from 6. Here we are going to have 0. Let us now use the quotient rule formula, whereby in the quotient rule formula we understand that d with respect to ds here is equals to v du with respect to ds, we subtract from u, dv with respect to ds, everything all over v squared. D with respect to ds is going to be equals to our v. V is equals to s squared. We subtract from 6s, we add to 34. Du with respect to ds is equals to 1. We subtract from u. Our u is equals to s. We subtract from 3. And dv with respect to ds is equals to 2s. We subtract from 6. Everything is going to be all over v squared. Our v squared is equals to s squared. We subtract from 6s. We add to that. At this point now we are going to have d with respect to ds is equals to, here now we are going to have 6s squared. We subtract from 6s. We add to 34. We subtract from, this is our first bracket, we subtract from, here we are going to have 2s squared. We subtract from 6s. We subtract from 6s. We add to 18. 18. We've opened that bracket and everything is going to be all over s squared. We subtract from 6s, we add to 34. S squared we subtract from 6s we add to 34. We subtract from 2s squared. Here we are going to have a total of negative 12s we add to 18. Here, sorry, we must have a negative of 18. This negative is going to affect here, and here we are going to have a positive also. Because it was a negative, so negative multiplied by negative is going to be a positive. Everything all over s squared we subtract from 6s we add to 34. On our numerator now we are going to have negative s squared. Here we are going to have a positive of 6s because negative positive of 12s. And here now we are going to have 16. Everything is going to be all over s squared we subtract from 6s we add to. Here we are supposed to be having squared, here squared, because it was our term of v squared from this point. Sorry about that, we are supposed to be having our v squared from our formula. And this is how you go about finding the Laplace transform of our function using the second shift theorem. Let us now meet in my next session whereby I will be discussing about the inverse Laplace transform into detail.